Hello, this is Engineering Statistics and Linear Algebra 18 EC44. We will today discuss about the model question paper of the VTU 18 EC 444 1 and 2. This is the EC 441. We are just discussing about the model 4. So the first 7A is describe column space and null space of the following matrix. Let us try to solve that. So A is given as 1 minus 1 and 0, 0. So from this you can make out very clearly that the second column is a linear combination of the first column. If you multiply the first column by minus 1, you'll get the second column. So both the columns here, the columns are not linearly independent. So therefore, this just corresponds to the pivot and this corresponds to the free variable. So x1 is the pivot and x2 is the free variable. So you can just try to write Ax equal to B, and in that case, the what you call, because you have 0, 0 in the second row, V2 should be 0, otherwise if V2 is not equal to 0, then it leads to inconsistent set of equations. Column space is a linear combination of independent columns, so we have only one independent column. The column space of A can be described by considering the inconsistency, that is B2 equal to 0. Since two columns are dependent, it's a line generated by the column 1 and that is represented by C of the first column 1, 0. Then the null space is the solution of Ax equal to 0, and A and X you can write over here. And then it will become, 1 into X minus of 1 into x2 equal to 0. And that will give us x2 equal to x1. And therefore, x is equal to x1, x2. x1 is as it is. x2 is equal to x1. That's why we are writing x1. And x1 you can take common. And 1, 1. So this becomes the solution for the, what we call, null space. The second one is B is 0, 0, 3, 1, 2, 3. You can what we call exchange R1 and R2, row 1 and row 2, then it will become like this. So then this is the pivot variable, this is the independent variable, because if you multiply this with 2, you will get this. And this again is the pivot variable because you have here 3. So you have two pivot variables and one free variable. So column space is a linear combination of the independent columns. So we don't have any of the rows as totally 0, 0, 0, so we can't describe in terms of B. So only in terms of the linear combination of independent columns. So C1, 0, 1, that is the independent column is this and the independent column is this, plus C2 into 3. The null space is again the solution Bx equal to 0, B you can write here, X you can write here, 0, 0 you write here. So that will give you, if you take the first row here, 0 into x1 plus 0 into x2 plus 3 into x3 equal to 0 over here. So that will give us 3x3 equal to 0. That will be x3 equal to 0. The second one is 1 into x1 plus 2 into x2 plus 3 into x3 is equal to this 0. And you will get it as 0, and that is x1 plus x2 plus x3 is 0. That's why we are substituting over here. That is equal to 0. So x2 will be x1 by 2, and that will give us the null space is x1 is 1, if x1 is considered 1, x2 will be considered as minus 1 by 2, and the x3 is 0. So then you need to multiply by c. Or if you consider x1 as c, then x2 is minus c by 2, and x3 is 0, and then you will get the solution. 7b is determine whether the vectors 1, 3, 2, 2, 1, 3, 3, 2, 1 are linearly dependent or independent. So we can write those three vectors in the form of a matrix, and then we can try to find the Gauss elimination or value decomposition. R2 will be replaced by R2 minus 3R1 because this is 3 and this is 1. R2 will be replaced by R2 minus 3R1. Then you'll get a 0 over here. That is the aim. We should get 0 here. So then naturally you'll get this as 1 minus 3R1, 3 into 2, that is minus 5, 2 into 2 minus 3 into 3, that is minus 7. Similarly, uh, this should be made 0. For that, we should write R3. It should be replaced by R3 minus 2R1. So 2 minus 2 into 1, 0. 3 minus 2 into 2 minus 1. 1 minus 2 into 3 minus 5. Then you can exchange the R2 and R3. Then you will get like this. Then R3 should be replaced by R3 minus 5R2, so that this becomes 0. So then you will get it as minus 7 plus of minus 5 into minus 5. That will be minus 7 plus 25. That will give us 18. So you can see that you have the three pivot variables x1, x2, x3. Therefore, it will be independent. Also, none of the rows is giving us a value 0, 0, 0. Hence, one can say that all the three correspondingly span the space of R cube. Therefore, they form a basis. 7c, we have not written the question here, so let us go back to the question paper. So 7c is this: u equal to 1, 2, 2, 2 minus 2, 1, w equal to 2, 1 minus 2. Then show that u, v, w are pairwise orthogonal vectors. Find the lengths of u, v, w and find orthonormal vectors u1, v1, w1 from vectors u, v, w. To show that they are pairwise orthogonal, you just need to take u transpose v equal to 0, if it is equal to 0, then they are orthogonal. V transpose w, then vw will be orthogonal if v transpose w is 0. wu will be orthogonal if w transpose u is equal to 0. So having found that, then u1 will be u into the length of u, v1 will be v by the length of v, w1 will be the w divided by the length of w. And that is what we have done here. So u transpose v is 1, 2, 2, 2 minus 2, 1. So that will be 1 into 2, 2, 2 into minus 2, minus 4, 2 into 1, plus 2. So naturally, this gives us the value 0. V transpose w is 2 minus 2, 1. And this is 2, 1 minus 2, 2 into 2, 4, minus 2 into 1, minus 2, 1 into minus 2, minus 2. So again, you'll get a value 0. So V and W are orthogonal. Then coming to W transpose U, we'll get 2, 1 minus 2, 1 minus 2, 2, 1 into 1, 2 into 1 is 2, 1 into minus 2. This is plus 2, 1 into minus plus 2 is 2, minus 2 into 2 is minus 4. So you'll again get a value 0. So this is plus 2, not minus 2. Therefore, they are pairwise orthogonal. Then each one, if you divide by their length, which is here the length of u, so it should have been double mod root of 1 square plus 2 square plus 2 square, that is 9. Then you will get the value as root of 9 is 3, 1 by 3, 2 by 3, again 2 by 3. Similarly, v2 is v divided by the length of v. equal to, again, length of V is 2 square plus minus 2 square plus 1 square. I should have mentioned double mod rather than single mod. So this will become 2 by 3 minus 2 by 3, 1 by 3. Similarly, the value of W1. Then the 8th A is apply the Gram-Schmidt to A equal to 0, 0, 1, B equal to 0, 1, 1, C equal to 1, 1, 1. And write the result in the form of A equal to Q1. So A, you can see that it's a unit vector. So therefore Q1 is equal to A as this itself. If it is not a unit vector, then Q1 will be A divided by the length of A. Then we need to find B, capital B, small b minus Q1 transpose B, Q1. So Q1 transpose is this transpose multiplied by the value of B, this one. So 0 into 0 plus 0 into 1 plus 1 into 1 will give us 1. Q1 will be as it is, same thing. So if you subtract, you'll get it as 0, 1, 0. If you see this 0, 1, 0, again, this is a unit vector. Therefore, Q2 is equal to B is equal to 0, 1, 0. If it was not, then we should have written B by the length of B. Here, the length of B is 1 itself, because 0 square plus 1 square plus 0 square root will be equal to 1. So having found the value of Q2, we need to find the value of Q3. For that, we need to find capital C is equal to C minus Q1 transpose C Q1 minus Q2 transpose C Q2. So this Q1 transpose C will be the Q1 over here. Then C we need to multiply with this. So you'll get Q1 is this, Q1 transpose will be this written in the row format, 0 into 1, 0 into 1, 1 into 1 will give addition of all that will just give us the value of Q1 transpose C, and that will be equal to 1. So having got that as 1, we can multiply it by Q1. Yeah. Similarly, Q2 transpose C also will be 1, and Q2 will be 0, 1, 0. So if you solve this, you'll get 1, 0, 0. Again, the length of this is 1 square plus 0 square plus 0 square root. That will turn out to be 1. So because C is unit vector, we see that Q3 is C equal to 1, 0, 0. Otherwise, C divided by mod C. Mod C is equal to 1 over. So Q is Q1, Q2, Q3, 0, 0, 1, 0, 1, 0, 1, 0, 0. Also, we see that A is equal to ABC, Q1, Q2, Q3, Q1 transpose, Q1 transpose B, Q1 transpose C. Here it is 0, Q2 transpose V, Q2 transpose C, then 0, 0, Q3 transpose C. So we can try to substitute over here. This just corresponds to the value of R, and you need not write all these things because we know over all this thing as a check. You can just see whether it is true at all. So we need to write the R from here, or R which is there below here from there, and that will be Q1 transpose A is 1, Q1 transpose B is also 1. All these are 1s. So therefore we'll get 1, 1, 1, 0, 0, 0, 1, 1, 0, 0, 1 as the value of R. 8th B is find the dimension and basis for 4 fundamental subspaces for the matrix which is given over here. So again, we can find the LU decomposition for this. This is already 1, and hence again this is already 0. We need not bother. We should somehow make the third one we should solve. So that will give us R3 is R3 minus R1. So we'll get all zeros over here. So therefore, we'll have this as the pivot variable, and this as the pivot variable, x1, x2 pivot variables, x3, x4 free variables. Further, because we have 0, 0, 0, 0 here, there will be inconsistency problem if the value of B3 is not equal to 0. Without bothering with all that, you can see that because we have two pivot variables, rank R is equal to 2. So dimension of row space is R itself equal to 2. Dimension of null space is n minus R, 4 minus 2. N is the number of columns. Dimension of the column space is R equal to 2. Dimension of the left null space is the number of rows minus R, 3 minus 2 equal to 1. So 1, 0, 1, 2, 1, 2 form the basis for the column space. 1, 2, 0, 1 and 0, 1, 0, 0. That is the two rows put in the form of a column. Form the basis for the row space. And then the other two, leaving the first two columns, will form the basis for left null space. The other row, leaving the rest of the two rows, forms the null space. Next is find projection of B onto the column space of A. So A is given, B is given. This is one way of doing it. Otherwise, you can always do A transpose A x hat is equal to A transpose B. Then you can find x hat is equal to A transpose A inverse A transpose B. Then multiply it by A. So again, it is just the same thing, only that we have put a formula for P here, right? So A transpose A is what we are trying to find first. This will turn out to be this. Then A transpose A inverse is, these two exchange and these two again exchange with a minus sign multiplied and you'll get this. And denominator will be 6 into 18 minus of minus 8 into minus 8. That will be the value over here. So we will get 18 by 44, 8 by 44, 8 by 44, 6 by 44. Then you multiply A with this whole thing. A is this and 80 A inverse is this. You'll get the value of that as this. Then you find the A transpose B, which is 112, 114, 127. You'll get 1727. Then P will be this whole thing multiplied by this, and you'll get this as what you call this multiplied by this, and whatever you get, you can write over here. And that corresponds to the projection P, small p. Projection small. So we need to find the projection of B onto the column space of, and that is what we have done. Then the next paper, 18 EC 442, right, which corresponds to Esla MOD4. The first 7th A is, let us see what is the 7th A in this question paper. So that will be let I is equal to VR be the integral mapping, IV is equal to 0 to 1 pt. Show that I is a linear transformation for integration. So that is done in the Esla MOD4 lecture 8. You can just go through that in the video which is put on the YouTube as well as it is in the Google Classroom. Next is determine whether or not each of the following forms a basis in RQ. So almost same as linear independence, except that we might need to write here an augmented matrix. So 2, 1, 1, 2, 2, 1 written in the column format, 1, 3, 7, then 1, 2, 2. Then you need to find the Gauss elimination or LU decomposition. So exchanging R1 with R3, it's not R2, R1 with R3, we'll get this. So this and this are exchanged, so we'll get this. Then we try to solve this so that the what you call second element over here becomes 0 and this also becomes 0. So for that we need to write R2 minus 2 R1 goes to R2 and R3 minus 2 R1 goes to R3. Then we'll get this and this also can be solved. Then after that, this should be made 0. To make this 0, we should write R3 should be replaced by 11 R3 minus 13 R2. So therefore, this will become 0. And in turn, this will become minus 7. Because of the reason that 11 into minus 3 will be minus 33. Minus of 13 into 2 is, plus 20 is 6. So 33, 26. Subtracted will give the value which is minus 7. And this will be 11b1 minus 13b2 plus 2b3. So all three columns have a pivot variable, therefore linearly independent. All three rows give unique solution because none of the rows is giving us the value 0, 0, 0. So therefore they span the space. So you have at least one solution. 7c is same thing as 7c of 18 EC441, so we are not solving it. So 7c is same of 442, whatever was there in 441. 8a is define vector subspace and explain 4 fundamental subspaces. So this is a theoretical question which is already done at the lectures correspondingly. You can just go through that. 8b is solve ax equal to b by least square method and find p is equal to ax if a and b are given. So for that again we need to write ATA x hat is equal to A transpose B. So A transpose A you can find over here. We'll get like this. A transpose B also you can find. Then x hat will be equal to A transpose A inverse A transpose B, and we are writing A what you call ATA, whatever we have got, inverse multiplied by ATB, which is taken from here. So we'll get it like this, and this will be left as it is, and then this total thing will simplify like this, and we'll get it. You can use a calculator also to find the inverse. So having got the value of A, you can just find out P is equal to AX, and having got the value of X from here, X hat from here, A is known, AX hat will be 1001111 multiplied by 1 by 3 and 1 by 3, and we'll get the value of the projection as this. Here C is the Gram-Schmidt process for A equal to this, B equal to this, and C equal to this, and the right result in the form of A is equal to QR. I'm not solving this and leaving it an exercise. I'm just writing the formulas. Q1 is equal to A by mod the what you call length of A. Then we find capital B, B minus Q1 transpose B Q1. Q2 is B by length of B. Then C is capital C is small c minus Q1 transpose C Q1 minus Q2 transpose C Q2. Q3 will be this C divided by the length of C. So having find Q1, Q2, Q3, you can get Q as the Q1, Q2, Q3. So having found the value of Q, then you can find the value of R as Q1 transpose A, Q2 transpose B, Q1 transpose A, Q1 transpose B, Q1 transpose C, 0, Q2 transpose B, Q2 transpose C, 0, 0, Q3 transpose C. The diagonal will become small a, small v, small a, capital V, and capital C. And these can be always found. Non-diagonal values or off-diagonal values can be found. So this is an upper triangular matrix. So with this, we come to the end of the solution for the model question paper corresponding to module 4.